Okay, so we're going to start 2.3, which is properties of functions. So we're going to begin by talking about even versus odd, which we kind of touched on something similar in the last unit when we talked about symmetry with the x-axis and y-axis. So another word for y-axis symmetry is to say that it's even. And let's recall, how do we determine if it's even? The definition of an even function is if you replace x with negative x, if your output after you simplify it is equal to f of positive x, in other words, it's back to the original, then that function is even. The most basic example of an even function is a parabola. An odd function, though, is similar to origin symmetry. And what that simply says is if we replace x with negative x, the entire function becomes opposite. Okay, so it doesn't simplify to the original function, it simplifies to the opposite of the original function. An example of this would be a cubic function. Okay, graphs that have origin symmetry have a symmetry line at y equals x. Okay, so if we were to graph that line y equals x, that would be a place or a line of symmetry. So let's go ahead and practice it algebraically. So the first thing we're going to do is we're going to replace x with negative x and see what we get. So if f of x equals 2 times, okay, and then inside of the parentheses, I'm going to put a negative x. And let's raise that to the power of, with a negative x, and we raise it to the power. We want to know, well, do we get the exact same thing out, or is it the opposite? Anytime you raise a negative to an odd power, your result is negative. Okay, so negative 1 raised to a power that is odd is going to stay negative. But negative 1 raised to a power that is even is going to become positive. Okay, so when I look at this first one, when I raise negative x to the power of 5, I get 2 times negative 1, which is negative 2x to the power of 5. And then negative 3 times negative 1 is positive 3x. And when we look at this, notice how this function, and I should probably replace this here because we're actually putting in a negative x. Notice how f of negative x is exactly the opposite of f of x. Okay, and because it's the opposite, I know that this is an odd function. Okay, let's look at question B. So again, I'm going to find f of negative x. I'm going to go through and substitute every x value for a negative. Okay, well, 4 is even, so that negative x is going to become positive. So it's going to say 3x to the 4th. 2 is also even, so the negative x becomes positive. And when we look at this, notice that it is exactly the same. Because this is an exact match, f of negative x is exactly the same as f of x. This is an even function. Okay, now let's go ahead and check C. Again, we have a negative x there, and we're going to set it equal to negative x squared minus 2 times negative x. So here, this first one is going to change to a positive because 2 is even. But the second one is going to stay negative. So because it stays negative, I'm multiplying negative 2 times negative 1, which is positive 2x. When you compare f of negative x to f of x, it's not the same, but it's also not the opposite. In order for it to be the opposite, the x squared would have to change to negative x squared. So the first term stayed the same, and the second term flipped signs. So this would be neither.